Okay, let's jump right into this explainer because today we're unpacking a massive, absolutely huge friction point for AI developers right now. We're going to look at exactly why a standard, widely accepted AI architecture just completely derails when it hits real-world data. Look, if you're building enterprise AI, understanding exactly where these current models break down, well, that's just as important as knowing what they can actually do.
So why are your AI solutions failing? Think about it. You invest the time, you write the code, you set up this totally state-of-the-art system, only to have it confidently hallucinate a basic Q3 revenue number from your very own internal documents. It is just incredibly frustrating, right? But here's the thing. These implementation breakdowns, they aren't just bad luck. Actually, scratch that. It's not luck at all. They stem from a very specific structural flaw in the tools we're using and the materials we feed into them.
The channel Anasup Consulting points to a highly specific intersection of technologies that's causing this failure. Specifically, we're talking about RAG solutions, complex documents, and vector databases. Now, this isn't just some vague complaint about AI, lacking reasoning or raw computing power. No, it's a super targeted look at what happens when these three specific elements literally collide on the factory floor. So, the core subjects of our investigation today are RAG solutions and vector databases. Right now, if you're building an enterprise AI tool, let's say an internal copilot to query your proprietary data, this is the standard playbook. You pair a large language model with these two technologies to basically bypass context window limits and, of course, provide factual grounding. Let's do a quick refresher on how these two actually function.
First up, Retrieval-Augmented Generation, or RAG. This is the framework designed to really anchor your LLMs to external, verified knowledge bases. So instead of relying solely on the model's pre-trained weights, RAG retrieves relevant semantic context on the fly and feeds it right into the prompt. It's totally engineered to make AI factual and reliable. How? By forcing the model to synthesize answers from your specific retrieved data, rather than, just improvising or making things up.
Now, to make that retrieval happen, the system relies on vector databases. This is the storage architecture built specifically for semantic search. It basically takes human language and translates it into high-dimensional embeddings. Think of it like creating this massive spatial map of meaning. When a query comes in, it's embedded into that exact same mathematical space, and boom, the database instantly retrieves the nearest neighbor vectors. It's highly efficient, it's incredibly fast, and theoretically, it's the absolute perfect backend for RAG.
But here's where the structural flaw really reveals itself. It happens when we introduce the catalyst, complex documents. You see, the architectural theory behind RAG and vector databases, well, it was largely built and tested on clean, simple strings of text. But we all know real enterprise data doesn't come in neat, flat text files. No way. It comes in beastly 100-page SEC filings, highly formatted multi-column PDFs, and incredibly dense technical manuals.
So standard embedding models absolutely thrive on simple data. Give them a straightforward article and they will map the mathematical meaning completely flawlessly. Complex documents, however, they are packed with spatial hierarchy. We're talking embedded tables spanning multiple pages, nested bullet points, footnotes, the whole shebang. The failure occurs because standard chunking strategies, they just read top to bottom, left to right. When you force all that structural complexity through a parser that's only designed for sequential words, all that precious spatial metadata is completely destroyed.
And that mechanical breakdown happens exactly at this ingestion phase. Because standard embedding models simply don't understand the visual layout of a nested chart or, say, a two-column grid. Naive chunking simply severs table headers right off from their corresponding data rows. Imagine a critical financial figure getting completely sliced away from its currency label and its date. Sure, the database successfully stores the individual words as vectors, but the vital context that actually gives those words any meaning, it's gone, lost forever.
The crazy part is the deployment pipeline seems totally flawless at first. You deploy your RAG solution, you spin up your vector database, and all systems show green. Good to go, right? But the very moment you ingest a 500-page corporate financial report, the system just shreds it. It treats those intricate tabular relationships like random, completely disconnected strings of text. So when a user queries those financials later on, the system just retrieves this garbled orphan chunk of data. Why? Because the structural integrity of the document was entirely ruined before it even reached the language model.
The result here is a complete and total system breakdown. Look, the AI model itself is actually doing its job perfectly, but the retrieval mechanism has essentially handed it a torn-up, out-of-order map to read from. So the AI generates an answer based on this mangled context, leading to wildly inaccurate outputs and skipped data. And let's be real, in a business setting, a single, highly confident hallucination about a compliance protocol or a revenue metric, that results in an instant, total loss of user trust. This isn't just a small bug, it is a fundamental architectural failure when dealing with the harsh reality of corporate data. This leaves all of us with a massive, industry-wide challenge. I mean, if the standard architecture breaks down exactly where businesses need it the absolute most, what comes next? Do we need multimodal databases that actually understand visual layout? Do we need entirely new pre-processing engines built specifically for spatial comprehension? Solving this specific failure point is absolutely the key to unlocking the next generation of AI. It completely changes how we should be approaching and building data retrieval systems right now.